Can you all see my screen?
Oh, yes, sir.
Okay. Okay. Today going to release the assignment. All right. I already upload in CN. You all can download it from there. And then I'm going to describe it here. Okay. Oh yeah, before that, yeah. Okay, our DC to AC converter, there is a typo in my slide. I already updated lah. So you can upload the corrected version. Okay, the error is here. The LCL filter, grid connected LCL filters, to find the grid inductor, right? Initially, there is no square, so there is a square here. It's VO square. All right. So that is the error I made. Okay, sorry. You know, when I key in this, I just forget to put the square, or else you won't be able to find the value of the LCL filters. All right. Okay, LCL. The second L. The first L is the inductor. Is a inverter. Inductor to help to smooth the what we call this waveform, okay, to convert it to sine wave. And this L is to connect, okay, to connect to the grid. So okay, please be noted on this. All right. Okay. So again, now we come back here. Okay, what I observed that there are still many of you didn't put your group name. Okay, so please do so. All right, maximum 3, minimum 2. So we will end up with 1 student. So please, one of the group, all right, you have to split out, become 2, 2. All right. If I receive a report with 4 names, okay, I will treat it as 2 different group of 2, 2. And the mark will be divided by 2. So that means the maximum possible mark you can get is only 15. All right. So please don't do that. You don't try to, well, I don't care already. I just put in my name and get marks. Okay. So just to make sure that, okay, you've all been warned about this. Okay. So the, what we call this assignment, all right. Basically, we cover PLO3 and PLO2. Okay, not much on the DC converter, but mostly for on the DC AC lah. All right, and then yeah, 15 marks. Okay, which is 30 in total. Okay, like I said, if you give me a group with 4 names, I will treat it as 2 groups. Each 2, and I will assume, because you are submitting the same report, right? I will assume it's a copy version. Therefore, the mark will be divided by 2. Okay. Date of release, week number 8. Okay. Yeah, demo and submission week 14. Every one of the group here need to do a online demo. All right, online demo. No need formal presentation, okay, but you need to submit a formal report. What I need to see is your live demo. All right. Okay. So the assignment is pretty straightforward and easy, I would say, because I already teach you all here. So the assignment is to model, simulate, and analyze grid-connected single-phase inverter. Right? It's all in my slide already, so you should know how to do it yourself. Okay. So yeah, like I say, it's already in my slide, and yeah, you just need to create it, design it, okay. And then the criteria is here. Okay, first of all, okay, it's a DC AC bridge inverter, grid connected version. Switching device, okay, you can choose MOSFET of IGBT, up to you, okay. So you can choose either one of them. Switching frequency, you decide. Okay, between 1 kilohertz to 50 kilohertz. And of course, once you decide every one of these, right, in your report, you have to explain or tell me why you choose, MOSFET over IGBT, or why you choose like 10 kilohertz, in between this range. There must be a reason, right? You can even tell me, oh, this is what Arthur is showing me in the class. Also can. Of course, that one you won't get that much mark. Okay, modulation type. Modulation type is SPWM. Okay, obviously because I only teach you one type. In fact, there are another type which I won't be covered. Okay, controller type. Okay, of course, PI already show you. Okay, or if you want to learn another type of controller called proportional resonant, also can. Okay, so I put it there as an option. Your DC source. DC source is 400 volt. Okay, your DC source is 400 volt. And then, of course, your single phase, right? AC output is 230 volt RMS. And inverter output power, okay, expect to be able to deliver up to 5,000 watt or VA, okay? And then our load type, of course, grid connected. There is no load, right? The load is the grid itself. So you must be able to show me that, okay, you can actually inject power to the grid, okay, by showing the active and reactive power. Okay, like this one, DC to AC. Okay, grid connected. All right. And then, of course, I expect you all to use the transistor, 4 transistor, to do it instead of using these blocks. All right. Later, I'll tell you why. All right. The answer is actually here already. It's just a matter of tuning. And because initially during the class demo, right, I found out how come I didn't upload it to the MATLAB. Now I know why already, because I plan to make this an assignment. Okay, so that I do not upload it into MATLAB. So you can actually, the answer is here already, just a little bit of here and there to make it. And of course, this is a very important part, V and I, P, Q, so that you know that you are injecting how much power into the grid, how much reactive power. So this is important to show that you are really injecting power to the grid. Okay, because this is not like our off-grid, right? We have a resistive load where how much power you can deliver is depend on the load, right? And of course, also the capacity of this inverter. But because this simulation, you literally can have infinite power output, all right? But for real one, there will always have some limit. Okay, so I will not upload into this into MATLAB file exchange already. Like I say, it's already converted to your assignment. And then okay, so you need to do this using 2 software. All right. So like I said, using MATLAB and another one using PLECS. Okay, later I will show you a bit of PLECS demo. Meaning that you will need to, that's why I need a minimum of 2 persons, right? 1 person doing MATLAB, 1 person doing PLECS. And in your report, this is what I've expected. There should be only 3 chapters. The first chapter is design methodology. So you just show me the modeling of MATLAB, right? And explain how you determine all the setting parameter, like, why you do setting that, So this one, okay, is running in more MATLAB. And then another one, same thing, but you model using PLECS software. All right, so that will be the first chapter. Okay, now I will advise for those who really follow You know, the class, every time I ask you all to do the MATLAB, you all do, right? So for those who really do MATLAB in the class one, I will advise that you take up the PLECS to do, because you will learn something new, something interesting. For those who are lazy to do it in the class, then you can do MATLAB. It's much more easier. If you don't even know how to do MATLAB, okay, it may be, yeah, because these two are actually quite same. Later I'll explain why, okay. That's my advice. Of course, I'm not stopping you that you still want to use MATLAB, okay, no problem. But if you really, because see, if you already follow my class, every time I ask you what do you do, you already have enough knowledge and hand-on skill on MATLAB already. So take this opportunity to learn PLECS during your what we call this assignment. All right. Okay. Then chapter 2, which is the result and discussion. This is the part, okay, where you need to do performance analysis, okay, including, you know, discuss the current, voltage, harmonic, okay, the power losses, switching losses, for converter efficiency. Remember how to calculate the efficiency, the power input and the power output over the power, okay, input. Okay, so you can calculate the efficiency. Now, efficiency is usually counted at many points. For example, it's in percentage. Take examples. Okay, you are required to do up to 5,000 watt, right? So it's every 10%. No? Okay, at 500 watt, if you inject 500 watt, 10%, what is your efficiency? 20% is 1,000 watt. How much is your efficiency? And so forth. Okay, I expect to see at least some point, not just one point, because efficiency changes at different power delivery. Okay, you will see a curve. You will see a very nice curve. Okay, in fact, the highest efficiency should be around 4,000 watt. Okay, you will notice, okay, all the inverter, that's why when you size the inverter for your customer for any PV application, right, you have to size in the way that they always achieve the maximum, okay, what we call efficiency. If you buy too big, the efficiency will go low. And of course, you need to do thermal analysis. That is the reason why you cannot use this one, because this one you cannot do thermal analysis, right? You cannot model the thermal thing in the transistor. So you need to use a transistor, again, then you do the thermal analysis. Okay, and then of course, yeah, for heat sink, obviously, okay, like I already told you, there's a website, you know, asking you to design a heat sink, right? You design one heat sink, put there and tell me, okay, my inverter, even at 5,000 watt, my temperature is only like 30 degrees. Okay, so you need to do thermal analysis. And both of these you need to do for MATLAB as well as PLECS, because both can do all this. Okay, of course, like the second, repeat the above for the PLECS. This, and of course, at the end, right, your conclusion and discussion is actually, there obviously will have some difference, not very big difference. It should be small difference. If big difference, something is wrong already. Okay, it should have a very small difference between these two software, so that you have to write down discussion. You know what are the difference? Okay, discuss the difference and why do you think that causes the difference. So that will be the assignment. Now, you see, maximum 3%, that's the reason, you know, right? If you got 4, it defeats the purpose, because one of them should master, I use the word, either MATLAB or PLECS. The third one, I don't know what you want this guy to do lah. So that's why you ask for 4, no way. Because obviously the only 2 is going to do the job. Okay, now the third one can be the one who write the report or the one who do the analysis and I don't know, up to you. Okay, so again, that is the reason I do not allow 4. You give me 4, I give you half mark. Okay, I repeat again, don't do this to yourself. Okay. All right. Okay. This is the Rubik's. You can see the Rubik's, right? 10 mark is on MATLAB. 10 marks is on PLECS and 10 marks is on the report. Okay. So these are the things that you should show lah. Okay, demonstrate full design solution with detailed modeling setting with data sheet support, comprehensive simulation result with detailed measurement. Okay, so in between 9 to 10. If you want to get 9, 10, you do all this. If you do like demonstrate solution with detailed modeling setting with data sheet, support comprehensive simulation result. That's all. Okay, then you will get within this mark lah. All right. Okay. Yeah. 2 page. Okay, any questions?
Sir.
Yes.
For the power loss that we're calculating, right, for the switching loss, right, is only for the 4 MOSFET we are using, right, the transistor.
Yep.
We are not calculating for other components, right? Only that 4 transistors.
Yes, right? Yes. Because you see, that one also will involve the thermal analysis, right? You will do the thermal. And then at the end, remember when I show you in the class how to calculate the efficiency is the input power and the output power lah. You just measure the input power, output power, then you already get the efficiency. Even you do not do this power losses or thermal, you still can able to know the converter efficiency. All right, but of course you still need to do the thermal thing lah. But so in case lah, sorry.
Sorry. So we need to do the thermal, the power loss for the transistor, and then also a power loss for the converter also.
Okay. In fact, you do the power loss for the converter is good enough already.
Oh, okay.
Okay, and thermal analysis is obviously for the transistor. Right. This one already teach in the class, right? You just measure the input power and the output power, you get the efficiency. And then like I said, you had to do it in different power lah. If you want to do it 1,000, 2,000, 3,000, 5 points also can, but usually people do it by percentage, at least 10 points. Because you will see there will be slight difference at different, power delivery. So, sometimes why in the electrical industry consultant, right, they don't oversize the thing because they oversize. For the customer, sometimes they say, I got money, I want to buy the big one, but you do not need that. He may think, how about future use or whatever lah. But you have to tell them, no, if I oversize, your efficiency will drop. Until you upgrade your PV file, only you get the max one. So as a consultant, you really need to explain. And of course, if they are not technical people, you can actually, okay, immediately you show them the simulation, you explain to them, this is what happened. Okay, and thermal analysis is for sure ready lah. And last time we do thermal analysis, I also explained that. Then you had to propose, what type of heat sink. Okay, in the real design, heat sink is a must lah. Okay, for all these inverter.
So for the design of heat sink, right, we need to propose we have to go to the website that you showed last time and model it, the 3D model up. Oh, okay.
Or you go to any website where you can buy those heatsink lah. Remember, every heatsink they will give you the thermal resistance, right? Let's say you don't want to design lah, you're lazy to design, but you know that if you get a heatsink with how many Kelvin watt will solve the problem. Then you just show me, okay, you propose to use this heatsink for your inverter, also can. If you don't want to design lah.
Okay.
Okay. Any more questions? You want to ask, better ask now or after this one, I will not answer any question from you guys already regarding assignment.
Sir, just now you say, right, the switching loss, right, they actually depending on the input of how many watt we are designing for, right, the transistor.
Yeah. Actually, you see the power loss and the switching loss is actually the converter loss already. The whole converter, right, the 4 core device causing the loss is the transistor. Let's say your input is 100, your output is 90. You obviously know that is 10 watt of loss, right? Then that 10 watt is actually caused by the switching loss and the power loss of the transistor. Then you divide it by 4, each transistor would contribute to around 2.5 watt of losses. It's a very straightforward calculation.
Also, we're actually testing it under the percentage for the loss instead of actually trying for the real value.
Yes, I mean, that is what I expect on the minimum you all can do. But for those high performance students, if you really want to impress me, you can do the detail switching loss. Remember the one I teach, rise time, fall time thing. You show in your report, say, sir, oh, I do solid one for you. Yeah, why not? That will give you a 10 mark, over 10 mark already. I feel, because you see, that's why I want to make this quite open in the sense that I had to consider strong and weak student. Strong student, I believe they can do it one. But how about weak student? I don't want to, because setting assignment that will fail all weak student, right? Weak student, if you do something simple enough, I won't fail you, you get your mark. Strong student usually want to impress me, right? They'll say, sir, we don't go and buy his thing one, we design our own his thing. Okay, why not, right? I'm happy to see this type of high quality report. All right. Yeah. Any more question?
So I was thinking, right? Can I model the transistor with the datasheet in another separate circuit from the off-grid, like to show that the power loss thing?
Also can.
Or it has to be
also can. Yeah. When you show the
okay.
power loss, then you when you do the simulation, right, the result should be very close. I wouldn't say exactly the same. And remember, when this transistor, right, during SPWM, okay, there are actually two transistors turning on at the same time. You have to be aware of that. But I think that won't cause a very different result, okay? Yep. Any more question?
Yes, I have a question, but can you hear me or not?
Yep. What's that question? No question.
Yes, it's me. Can you give us an idea what to expect between the differences in the Simulink and PLECS?
Oh, of course, this is your assignment, right? When you do it, only you will know. After this one, I will go to PLECS one round for you guys, all right?
Okay, and also about the student license, did you manage to get it?
Oh, yes. I managed to get the license. Again, I will explain about it later.
All right.
Okay. All right. So yeah, like I said, I think now you all should know, who to do PLECS or not already. Like I say, I advise strong student to do PLECS. Good for you, right? You learn both. Okay. Wait. Yes, Dr. Masane. Hi. I'm having class. It's okay. What's that? Oh, okay. All right. Thank you, Dr. Masane. Yeah. 这个是一个中东的老师对，他其实是波斯人 ，Persian， 对，很特别的5G， 你有什么5G问他了 ？Okay. All right. So now, okay, I know that some of you may start to worry. Oh shit, what is PLECS, right? The sir never thought about it. That's the challenge of your what we call assignment. But okay, I also have my reason why I chose PLECS. Now remember, in my very first what we call class here, right? I actually show a few software, right? These are the top software in the world. Top, okay, that for power electronics. So you can see that there are actually 5 of them only, not many, okay? So PLECS is one of them, all right? So PLECS is one of them. So, okay, this round I decided to choose PLECS. Even personally, I've been using this, it's actually quite good, I would say, all right? So PLECS is one of them. Okay. Now, another thing is that the website, right? Okay, you just type PLECS. Okay, it should come out in the first place. So you can actually download it here. Okay, there's a PLECS website. Okay, you go for standalone. Okay, it's compatible with MATLAB. You see there's a PLECS box set. You can actually install PLECS inside MATLAB and use it. But I advise you to use standalone. Okay. Okay, so all right, you can download and install. Now, when you install, right, it will, okay, like in this case, I already installed. I will just show you PLECS. Okay, you see, I have no license now. So you got two choices. One is to start in demo mode, okay, or you install the license. Now, demo mode, you can use everything except you cannot save your model. Okay, you cannot save. You can create on the spot. You can run the demo, everything got, but you cannot save. Okay, so still good enough for you to for those who are learning and try to play around with. And then, okay, two types of license available. Okay, one is the student, not say student, it's a trial license. Trial license, right? You can actually get it from there. They will give you, I think now they already increased up to 90 days already. Last time it's only 30 days. Okay, so it will give you 30 days or up to, it's more than enough, right? Our time frame here, okay, to actually use it. But the good news is that you can see the email here. I managed to write to PLECS and talk to her. They actually agree to sponsor UCSI, okay, 50 license for free for 2 years. Okay, I just received this. You see, it's Wednesday, last night. I thought I have been talking to these people for months already. They agree to provide us the license. So now I'm waiting. I'm forwarding this to our UCSI server. So they need to do the setup. So it will like be using MATLAB. You just install. Once you connect into UCSI network, you can use the software for free. 100% fully functionable. So yeah, for the next coming 2 years, okay. But it gave us so late. But anyway, I would do a workshop, but not this semester next semester where there's no power electronics. Okay. Maybe you all, if you want, you all can come and attend or recommend your friends who is going to take Power E next year to come and learn it first. Okay. So this one may take some time. I hope it can be done within this week, but I can't tell. But if you cannot wait, you say, no, I cannot wait already. You ask for student license. They will take another week. So, you know. Okay. So these are the good news. Okay. We are going to have this, and this license is not cheap. Okay. So, okay. You can see the price here, if I'm not mistaken, store. Okay. Trial license, you can get the trial license here. Okay, students. This one 1 year, but I already get 2 years, so don't worry, we get more than that. Okay, now you can see that you can have also install the block set for Simulate and MATLAB. Okay, and then if you look at the price, okay, if you look at commercial, commercial means that company use it to produce, to make product. For example, Hitachi, Japan, ABB, they are using PLECS to design their inverters. And you guess how much is a license? You see, it's written here. Okay, now the one that we have is PLECS called, concurrent license. It's 12,000 euro. 12,000 euro. Multiplied by how much? 5, right? So the software you are using now is around 50,000 Malaysian ringgit. Okay, of course, yeah, I'm not sure they were going to renew for us in the next 2 years or not. Make good use of this time. Okay, yeah, to learn this. Okay, you can, learn all this. So it's a very expensive piece of software for commercial because they're going to design product and sell. That means this product is so good in the way that industry is going to use it. Of course, academy is a bit cheaper. Now you look at academy like university. Okay, it's only 1,002. Okay, you use for teaching, but that means you cannot design and then make it a product and sell. Okay, still euro, that's 5,000 something lah. Okay, for you all to learn this. Okay, software. Yeah, please don't waste my effort of talking to them, blah blah blah, to get all this. All right, because you see, this is really my effort. You know, if I don't do anything, I can just sit down and ask you all to eat yourself, right? But I take one more step to just say, okay, please help my student, give them full license so that they will learn. But I know that what happened is that 100 over students, maybe the 30 group, each of you use one. And after this semester, you forget about the software already. So cruel, right? This world. Always those lazy people will get the thing and hardworking people will get nothing, right? Okay, anyway, enough bullshit. Okay, now the good thing is that you can look at the power electronic. They give a lot of this example and model here online. And for example, you want to look at okay, DC-DC converter, maybe you can click. Now this one you can try it, okay, without installing PLECS. You see, of course you cannot change the circuit learning lah. Okay, you want to change, you can change. For example, you can change the value here. Then you can simulate this on the spot. Okay, you can click. Now it will show you the output. Okay, so that's the strength of it lah. You can play around with, and they are very support. Okay, they got applications, examples. They got tutorials. Okay. Okay, there are so many. They all got video one. Not all, some video. Most of them got a PDF. Okay, for you to learn. Okay, they are inverted. No worry. Okay, PLECS. If you look at PLECS. Oops, what happened? Okay, let's see. Thermal application. I remember I see power distribution or power generation. PV also got. Let's see. Single phase PV inverter, 3-phase grid connected PV, but we don't do PV part, right? We just put a battery, right? So yeah, there are already examples here. There are files for the models for you to play around, do a bit of modifications. Because we don't cover the DC-DC side, that's why I remove it, just to be fair to all of you. Okay, so support are there. Okay, not to worry. Of course, you can. Another strength is that you can, once you design, right, you want to program into not Arduino but those microcontroller. It actually allow you to do so, or with this free 2-year software. You can do the prototyping, okay. But this round we don't do any what we call this hardware, so you don't need to worry about it. You can actually program this one. You buy one from this Texas Instrument, then the model control, you can download into it and connect to the real inverter. Okay. Okay. Let me see. Now, like I said, the strength of this software, okay, is that it has been used in ABB. Okay. Hitachi and ABB, they're actually using this to develop their products. Okay, so Hitachi, all right. So you can see that they are actually using PLECS, okay, remember the traction, the train, renewable energy, and maybe we look at the topology first. Okay, now these are all run, okay, by PLECS. Of course, when you want to, it did something like the one that you can run online, okay. This one takes some time to load because it's connected to PLECS. You see, here is written, okay, power control, blah, 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 whatever. okay, simulation are based on the widely available PLECS software. Okay, they can do the turn on switching loss or whatever thing also lah. So you can see PLECS are so good in the way that, you know, even renewable, okay, so many things like EV, you know, okay, you click one of these. Wow, this one takes some time to load. Okay, so of course later, right, when it load out, right, okay, you can actually test the IGBT they use for their inverters. Okay, of course you can download their menus. The menu will tell you, you know, how to, okay, let me just download one set and have a look. And once you have all this information, right, you can model in PLECS. Right? On this one. Oh, still in the halfway of downloading. Where is it? You see, come out already. Okay, so for inverter, let's say, still can, I have to wait first. Maybe I choose this. Okay, simply choose one of the transistor. They use the IGBT, then you can simulate. So you will run the simulations. Okay, it will take some time. Okay, but anyway, like I said, you know, it's based on PLECS here again. Okay, when you click, it will show you the PLECS software. So what I want to explain here is that you know, I know some of you will think that a waste of my time to learn something not useful just for the assignment, right? Like I said, you know, I have to show you that this is something useful, okay, because the industry are using it, okay, for their product that cover all range of, you know, all this type of product, okay. They develop using PLECS and they allow you simulation, okay, then they actually use it in their product. So it's something useful. And also another proof to show it to you that, you know, how useful is this or why this software is useful. Okay. Okay, so okay, let's see. Okay, I believe you all heard about IEEE, right? Okay, IEEE got a lot of these chapters. Okay, so one of it is IEEE Power Electronics. It's one of the top, okay, these magazine and journals in the world, not just in US or Malaysia. Okay, anybody talk about the latest inverter, the latest thing about power electronic, you know, you can have a look on this magazine. So 1 year and only 4 issues. You join as a member, then you will receive this magazine. Okay, and then let me see, because PLECS is advertising, you know, the what we call this their product okay, in this magazine. Oops. Okay, let me see. And of course, yeah, to advertise here is not cheap all right, because they know that those who read this magazine is IEEE. Obviously, you are EE student or EE people in the industry, right? So that you only read this one, and obviously you have something to do with research. Okay, you had something to do with research. You see, PLECS. PLECS. Okay, so this is the hardware. So they advertise it almost in every issue. What does it mean? You know, there's been, if this is not good enough, do you think the researcher in the world who develop new inverter will bother to use and see it? So it has its value here. Okay, it has its value here. But now you may ask why you don't see MATLAB here. Okay, like I say, MATLAB is a very general type of software where it's not limited to Power E, right? It can do aircraft, everything. So MATLAB is a very general. That's why it has one problem. Okay, about the solver thing, you need to choose the right one to get the best result you can. Okay, but advantage is it widely used, of course, in the world. But PLECS, it does not do anything except Power E. That's why this is the strength of it. And then what we call, they develop this PLECS, right? Okay, actually the one who developed PLECS was a PhD student who is using MATLAB. That's why he found the problem with the MATLAB. Okay, so that's why upon graduation in 2002, he started up this company. So it's 20 years already. So he started up this company and they developed PLECS. Okay, and that's why PLECS can work with Simulink. And you look at PLECS, right? All the things or the components are very similar to Simulink. Now let me just show you a bit. Okay, now for example, okay, you want to open model. Okay, and you see the scope. You can just drag and put here. There's a scope. Okay, and then you go electrical. Okay, and then let's say you look at the source. You have a DC source, right? And DC source is here. And then power module. Okay, you can choose to use this power module or the transistor here. So, and the good thing is that you can see the drawing, because this student is EE student, obviously. And MATLAB is not designed for EE only, right? So that's why when you do the drawing, not so nice, but this one you can see it's so nice, the schematic. Everything, you double click, then you can do the setting. Okay, and double click. Okay, you can do. You see, almost like this Simulink setting. Okay, and of course, simulation. You click this or Control T to start, and you can set the parameter. You see, almost like Simulink, right? Start time, end time. Now, the beauty is that it's a solver. You see, Simulink, we got so many solver, and all solver mostly they work, but we don't know which solver is best, right? But this one, you see, if we go for fixed step, there's only one solver, that's all. And if we go for variable step, only two solver, stiff and non-stiff, that's all. You don't need to worry about the solver that show in Simulink so complicated, we don't know which one is which one, right? So because this is so specializing, okay, in Power E, okay, so that you can, what we call this, you can actually make this thing much more simpler. Okay, obviously they also have this thermal, like I said, see, they got thermal, okay, connectivities, source, okay, meter, convert. Okay, there are video in the YouTube also to teach you like that. Okay, they even have a heat sink. Okay, like the one you want to cover which part, okay, of this, okay, of this one. Let's say you can put your transistor inside here. Okay. Where is the transistor? Power semiconductor. Okay. Okay, you can do something like that. Okay, so there are videos for you to go through in YouTube as well. Okay, teaching you step by step and their website, which is good enough already. Okay, which is good enough for you all to do that. Okay, you may notice that there are some components not available. Okay, not available. Okay, remember it's the same thing. You can, as long as you understand, okay, the theory, you can develop it. Like for example, I will show you SVWM. You're going to use it, okay, for this, what we call this assignment. But when you go to control, it's under control, under modulator. and there is no SPWM. It's only got PWM. So how? Okay, we can create this. Okay, PWM, right? Okay, I'll just show you the way now. We go for the source. Remember, we need a sine wave. You see, almost even the symbol also same like this. Maybe I need to zoom in a bit so that you all can see clearly. Okay. Okay. Big enough. Okay. All right. When you double click sine wave, it's the same, right? 1. Okay. The frequency is what? 2 pi, right? 2 pi. Okay. Multiply by 50 hertz. So you generate a 50 hertz. Okay. So you generate 50 hertz. Stop, you connect to there. And then you will have output. Okay. And then double click. Okay. Okay. 1000 or 500 lah, like I did last time. The rest no need already. Okay. Because this is symmetrical ma. Or if you don't understand how this thing, you can click help lah. Okay. You can click help. It will explain to you. Okay. This is how it works. So this is symmetrical sawtooth. Okay. And then the simplest way to test it out is that, okay, I think we can test it already. Okay, we can change the time into 1 cycle, right? 1 cycle is 0.02. Click OK, and then we run. Okay, one more thing. It is very fast compared to, see, you already got the speed. But remember, we need to have the 4 output, right? So how to do that? Okay, of course, in my slide, I already explained, but anyway, I'll do one round for you guys to see so that you know how to create this SPWM yourself. Okay, okay, we have the source continuous. Okay, we need to have the mathematical function of gain, because one will do the positive cycle, another one will do a negative cycle, right? So -1. We do -1 because we need to switch 4 transistor, right? So we need to copy paste. Okay, so we will have another one. Okay, and then we need to have 2 conditions, right? Greater than and condition logical. Okay, we need to have this condition. Compare. Okay. I forgot already. Greater or less, you all have to check. Less than 0 and greater than 0. Okay, you can see the equivalent in my slide where I'm using the. If you look at my previous later I will see. Okay. Really forget already which one is which one. Anyway, it will produce the 2. Okay. Try this one first. Okay, one greater, one lesser lah. Okay, which one is which one? You confirm yourself. Okay, and then here you got input 1. Here you got input 1. Okay, and then of course the other one is here. Okay, if you don't want all these words to come out blocking, right? You go format. Just do the show, uncheck the show name so that it won't be able to see the thing that's blocking, right? See here also like Simulink already. Okay, so that you can have okay, scope. Now I want to see 4, right? Okay, same lah, like Simulink, you open up the scope. You can have a scope parameters, number of plot 4. Okay, so you can see there are 4 plots coming out. So it automatically become 4 plot here. Oh, and then you can just connect 1, 2, 3, 4 for your transistor. Okay, so now just run it. Okay, see, very fast. It's already done. Okay. Okay, yeah, this one's the correct one. If wrong one, you will see already. Okay, so this one correct. Okay, here we go. We got our very own SPWM in PLECS. Okay. SPWM in PLECS. So you can use it to switch your transistor. Then obviously you can make it a blocks like this MATLAB, right? You can, let's say, group it up here and then make it a subsystem, create subsystem. It become 1 blocks. Okay, that will do the, yeah. Any questions? Hello? Or you already say none of my business. I will ask those who want to join in my group to use PLECS.
Sir?
Yes.
Sir, if we download the PLECS now and choose the trial license, can we change to student license after you get the university sorted out?
You don't choose any license first. You just do demo first. Like what I show you, play around with this. The only thing is that we cannot save. If I want to save, I think you see it's not allowed me to save. Okay, then until we get the license, or like say like if you don't want to wait, you can just go for a trial license. I think it will take a few days to get back to you. Yeah. Now, first thing to do is to download. At least, like, you know, you can play around with this, right? I believe it will take you some time to familiar, okay, with the, you know, with all the tools you need lah. Okay, but the tools you need is all here already lah. Okay, so this is one of them. Okay, and yeah, to measure the real power and reactive power, there also no block here, but you can still do it like what I show you here. You create your own one. Okay, that is something. That's why I recommend those who already know MATLAB well to do this. Okay, in order to you know, to work on this. Like for example, in MATLAB, if you want to, I have to wait to open this one first. Okay, like for example, in PLECS, there is no these blocks, right? There is no what we call this. Okay, wait. You need to measure the power, right? There is no PQ block there. But this is to measure the real power and reactive power. Mathematically, you all study this in advanced circuit theory already, right? You know the equation, how to calculate. Same thing lah. You have to create this in PLECS. Okay. Okay, we wait while waiting for this one. Okay, I already show you this. So there are only 2 things. The rest is all there lah. The PI controller, everything is here already. Okay, the PI controller, I'm not sure it's in discrete or what. PI controller is here. They got discrete and continuous, maths, filters, THD. Okay, they got THD, they got Fourier transform, they got RMS. Everything is here, except this SPWM and PNI you need to create lah. Okay. Okay. And we have the target. Okay, this one is for hardware. You can program straight away using this one. It's so powerful. Actually, I like this as well. If you ask me just to do power electronic, that's why I want you all to see it yourself. Which one is better? Why there are difference? In terms of schematic drawing, this one already win over MATLAB already, right? Because they are drawing standards kind of drawings. Okay, and then simulation is super fast. Trust me, when you run both at the same time, you will see who completed the simulation first. Because this, like I said, it's not said MATLAB is bad, because MATLAB have to cater for many things, not only Power E, mechanical, whatever. But this one is it's just like specialist lah. You know, you go and see specialist doctor. You say I only deal with you this problem. Other don't ask me. You go and find other. So they are specializing in Power E. And the good thing is that, you know, like I said, it has a very close relation with MATLAB. Okay, see now you can do the simulation and everything. This is on the Hitachi lah. I mean, you know, Hitachi, Japanese company, you know, and ABB, they don't simply say this is good if it's not really good for their product, and they're selling all this product, you know, for a few 100K one, you know. If they don't, I mean, if PLECS is not so reliable, how do they put it on their website like that? Say, okay, you know, the product you are buying is based on this simulation, right? So this is something good enough lah, I would say, you know, for you to learn this software, okay? And if you go YouTube, there is a channel created by this PLECS as well, okay? By this PLECS, so that you can, there are a lot of tutorials inside there, you know, spend some time, watch it. Okay, let's say, okay, PLECS. In fact, the website also have the same video lah, okay? So introduced to standalone, you go to the playlist or the video. Yeah, tons of example. Okay, so even tell you how to program the hardware in future. You want to do those, yeah, postgraduate projects or whatever. So many of them. Yeah, some of the answer is already here lah, I can tell you. Okay, thermal analysis. Okay, let's say, you know, they are how to do the thermal analysis. Okay, let's say PLECS, thermal model, thermal library, you know. So they got part 1, part 2, you just study, try to understand. You see, in their website, they already have all this, how to model this transistor thermal, okay. And apart from that, I also upload the 2 training material which I obtained from PLECS, the official one, okay, in your CN, okay. Okay, in CN, I have uploaded these 2 material. You will see lah in the assignment there. Okay, so these are their material, okay, about, of course, you don't see the mechanical term, you may see thermal simulation and so forth, like some exercise, okay, for you to have a look. Okay, you want to learn something, okay, this is a slide. And then they also have a tutorial. Okay, model power supply, you can step by step. Okay, this one is what last year student is doing. Last year, I also asked them to use PLECS to do the power supply, our charger lah. Okay, DC AC converter. Okay, so yeah, but last year we don't have license, so the student need to use the trial license. This year you all got the license to do, so you can play around with it step by step, you know. Or there are so many examples you can try. Okay, you can try. All right. So yeah, play around with it. I think the multiplexer thing also the same. Okay, so there are 2 materials, should be good enough for you to start with lah, for the PLECS. And then what else? We have this. Oh, okay. Like I said, PLECS also widely used in the research community. Okay, let me see presentation now. So these are the material where PLECS is sending me presentation. So the tutorial I also obtained it from here. But the video, like I said, is already online, so not to worry. You can actually find it online. Okay. Not here. Material workshop. Oh, where is it? This. Paper. Okay, like I said, you know, this software not only good in use in industry, but also people have used it to publish journal. Okay, like in IEEE using PLECS. You see, this is a journal paper 2012. Okay, so you know, journal paper, it means PhD student, right? They want to do PhD, you know, they actually use PLECS to simulate the wind turbine, you know, and get the result. You see, the result means that it's so good, okay, or so close to the industry, so the journal actually accept it, okay, to be published, all right, in these academic journals lah. So journal doesn't mean that I mean, this PLECS not only good in commercial but as well as research community. Of course, same for MATLAB lah. A lot of people they use MATLAB for this one IEEE transaction of power electronics. This is the top journal in power electronic in the world, so they can actually accept this. Okay, for people who using PLECS, right, to do this. Okay, this is space vector modulation. Apart from SPWM, there is a method called space vector SVM. Okay, for modulation, which I didn't cover lah, because this is good in controlling the torque of the machine. Okay, SPWM are good in controlling the frequency or the speed of the machine, but not really good in controlling the torque. It still can, but not so good as compared to FVN. All right, so modulation type, you know, but it will actually affect the performance lah. But for most grid inverter, they use SPWM is good enough, unless you want to simulate the inertial force of the real generator, then you may need to consider using SVM, okay, which is not required in your assignment. You just need to use SPWM, that will do. Okay. All right. So I think this is done. This is done. Okay, almost got him. Okay, see, talk about assignment, just need to use, you know, one class already lah. All right. So any questions? So you double click, you can see open.
Dr. Rodney,
yes.
How long do you mention just now that the UCSR IT will take to set up this PLECS? What's the use?
I can't tell lah. I already emailed the IT guy, and depend on how fast he do the job lah.
Okay.
Once it's done, I will upload the license, okay, to CN. So you just install that license, it should work. And maybe he need time to test whether it's going to work on this or not lah.
Great,
Yeah.
thanks.
So the license is one group, one license.
Okay, he only gave me 50 license. 50 license means that 50 students maximum can use this PLECS at one time. Not say group it's individual lah. But you have been in UCSI so many years. Do you think our student will be so hardworking, you know, to open at the same time? I don't think so. You look at the group here. I look at it also no more already lah. Luckily, I only asked for the minimum. You know, it's so hard already. You know, wow, if I ask for 200, then only like 30 students use it. Hey, I have to explain one. You know why? You see, when I look at this power E, the group thing, I already know mode already, to be very honest. You guys, I try to get the best of the thing in the world for you guys. You see, this is how you guys treated me. Don't even bother to put a group. If I put, you see, we got 115 student, 40 student, and I believe only one guy will do the job lah, based on what I know UCSS student behavior. Of course, there are still some good students who are willing to learn, but not many. So 50 license should be good enough. You look at the point here. See? Now, like I say, it's up to you. Okay, don't tell me. You see, the fees you are paying here, suppose I just tell you what is Power E, everything on paper, end of class, bye-bye. I do so much model for you all. I set up the MATLAB file exchange. I teach you all step by step, including one of the top, on the top thing in the world. Okay, sorry, I think you all cannot see. See, when I look at this yesterday, I really know mode already. Shit, you know. And then you all complain, UCSN don't teaching me the best thing. You are going to get one of the best. If you don't trust me, ask your friends study outside UCSI. Do they have the chance to use this or learn this in their entire E&E? Okay, this is already the best I can do for you all. Take it or leave it. Okay, license is only 2 years, because if I cannot prove to them, you know, UCSI students are so keen to use, you know, please give me another 2 years. If they see, shit, only 30 students or less than 10 students use it, then I say sorry. Then we were going to use the trial license for the rest of the life already. Yeah, like I said, yes, okay, you all look at this lah. Put yourself in the shoe. You are trying so hard working to get things done for you, and students say, sir, I just don't care. What kind of feeling you all have? All right, so any more questions? Yeah. Wow, why so quiet? Everybody go to there and try to update the thing. Don't update down, okay? Update later lah. Got everything, you better ask now, okay? Because coming, right, I will just focus on the class already, because we are really seriously run out of time, you know? So anything on the assignment, PLECS, you can ask, you better ask now lah. Already show you this one of the very important thing, SPWN created for you guys already. Of course, now it's though I don't want to save, it's I cannot save, because I also don't have license. Although I used to have the license before, I expired already. And then there are many models actually available already for you all to just download, open it, and modify it if you want. I know in the website here, right? If you go download, like I said, I show you just now, it's under the stand-alone support tutorial applications. They are all here. Okay, there are also a forum for them to ask and know how to do this and that. Okay, you can even write a script, but this one is not within our scope. Okay, so there are many of them here. Okay, download those relevant one. Okay, YouTube also already have tons of information. Okay, now how to buck converter thermal model, right? So how to model the thermal thing. So one student take up one. I mean, topologies is the same already, right? So if the MATLAB work, this one should work. Okay, like show like industry use it. Okay, IEEE research, top research also using it. Okay, but this one because they make it in the web so that you cannot simply change. You can only change the parameter here. And for the component wise, is exactly the same like passive, right? Register, inductor. Okay, you can just rotate them. Okay, left, right. Okay, rotate. Okay, I have the terbalik already. And then capacitor, just the value, just double click. You can change the value inside. And then you connect them. Yeah. We have scope. I think scope is also similar. Okay, we got source. You just need a DC source, right? That's all. For your case, you just need a DC source and double click. How many watt? That's it. So simple, right? PI controller plus minus. You just need to use the electrical control and then system. Okay, we also have the signal, multiplexer and so forth, demultiplexer, or you want to see the sine wave, you just add another one, set another parameter. Okay, at 5. Okay, and then you can connect this and you can see the sine wave, right? And then run it. See, can run it like that. Okay, even you see there are components here are not connected. It will still run, for those already connected. Yeah, should be very straightforward. Okay, LCL filters. 4 transistor you need to create. And then the measurement of the power. Okay, so power is just like, there are mathematical blocks. Where is it? They were under control. It's actually very similar to, we got multiplication, sum, product, okay, and we have also the sum, okay, all different box. Sum minus this is same, even the setting. Okay, you want to have round or rectangular. Yeah, they are close friends. Okay. You know how to use Simulink, you shouldn't have any problem here because it's much more faster, easier, except there are some blocks that may not be available, but you can create it. Okay. Okay. So any questions? Oh, why so quiet?
Sir, I have a question here.
Yes.
Because right now, right, we are doing the same thing using the PLECS and the MATLAB, right? So, ask us to expand the parameter, right? So we need to expand twice or only one time.
Oh, parameter only one time because if the inductor is 1 millihenry, the MATLAB and the one should be the same value, right? Yeah, it's one time, yes. You only need to tell me the difference. When you simulate, right, you may have.
But there's only to the result, right?
Yes, only to the result. Yeah. Because the calculation to obtain all the values should be the same. Like, let's say, if you decided to use 20K for SPWM, both should be run 20K, right? Now, both model, value, everything, you just need to show me one time. And then both of them should have the same value, okay, to run it. Then you observe the difference. For example, maybe the THD will be a little bit different. Okay, the power may be a little bit different, Just try to explain why based on your understanding of what you have studied so far. Okay, that will cover a bit of circuit theory, advanced circuit theory knowledge you have. So the difference between, you see, I expect no fail in this assignment. Okay, because you can at least do the MATLAB already. Let's say the one group totally don't want to do PLECS scan, you lost 10 marks. Okay, then you focus on the MATLAB and the report, right? You roughly can get 10 to 15 marks, let's say. Okay, half of the mark already, so it shouldn't be any. But to score like 25 to 30, I will set a very high bar there. That's mean if you give it normal thing, you will most likely just get around max 25. Now you want to hit, like 28, 29, 30, you need to give me all the very detailed explanation and show me, really put in effort and do that. So that will make the difference between three group of students here. a group of students don't bother to learn thing new. They just want, okay, sir, just pass me, okay, end of story, fair. I mean, this is what you want, right? I'll give you lah. And the other group of students, for some reason, they just do what they can and then they don't want to put in extra effort. Okay, then they will deserve, because they already good enough, right? They do what they can, but they don't want to put in extra effort. You'll get like 25, okay, or 20 or 25 over 30. And for the last group is the elite group in this class says, sir, you know, don't underestimate me. I will show you what you don't know. Wow, even I also don't know, you know. Wow, I tell you, I give you 30 over 30. Yeah, there's only 3 groups of students here, okay? Among these 115 students. Of course, there may be one very low percentage and they don't even bother to do the assignment. So you and your group member now decide which category you want to fall in. Okay, and this is the best I can provide for you all to learn in this semester. Of course, every year different, right? I would have different, I don't know, what type of support I can get from all these people. But personally, I have been using PLECS already last time, so it's good enough lah. I mean, I look at the industry and the research community have been using it, you know, for all these solid results. If it's not good, if the difference are so big, do you think ABB Hitachi going to use it for their product? Later they say, hey, I got 5,000 watt output, but the product come out only 4,000. Wow, 20% different. It's big already, you know. And let's say if the thermal design is so bad, then imagine if they design the heat sink in the simulation show it can give a temperature of 30, but in the real one, the temperature is actually 50. What will happen? The inverter will overheat, right? And overheat means that it will shorten in life. Then the warranty, you know, may not be able to cover. So all these things lah. Okay, so yeah, usually I will spend one class just to talk about assignment. Okay, I hope you all will appreciate, you know. Yeah, actually, you will continue want to learn. There's so much in power electronics. Okay. So yeah, any more questions? I hope I don't miss anything lah. CN everything outload except the license. Like I say, if you cannot wait, you just use the trial. If you can wait, you know. Hopefully lah by next Monday or I don't know. It depends on our computer IT guy here lah to install. But to play around, the trial is good enough lah, because you know the one thing you cannot save on him. Well, sometimes it's good you don't save when you learn this one, so you can do a few times. Or you all can start with MATLAB first, right? Because MATLAB is already there. Then you show the guy who do back, okay, these are the MATLAB, okay, you just follow every value, you no need to bother about calculation, everything, right? You just create, and then, yeah. Oh, yeah, MATLAB, just now I opened for one reason. Okay, let's say you want to know how to calculate the real and reactive power thing, right? When share screen, everything slow down. Okay, so you can actually find. Okay, the block that allow you to calculate this power real, and let's say you also forgot about what you have learned in your advanced circuit theory, then the easiest way, and also this is the way I used to do it also lah. You know, even at my level, right, all those circuit theory, advanced circuit theory thing are almost forgotten already. Okay, I think it's under measurement. See, okay, this block PLECS doesn't have, right? But just now I already show you how to create it, right? Oh my God, come on, come on, come on, come on. Okay, 2 ways you can learn how to create this. But make sure you double check it. The lazy person want to know how this thing works, right? Go to mask. Look under the mask. Copy this into PLECS tip. But let me warn you, if you copy directly, you will get the wrong answer. Okay, there is one block here causing the problem. So again, if you don't want to get the wrong answer, please verify this. Okay, double click this one. Go to help. This is a stick for you already. Okay. And the equation to calculate this one is here. All right. So equation given, block given. Okay, you should be able to create PLECS. All right. But let me warn you, if you just buta, copy this one, you will get the wrong answer. Okay, there is something not supposed to be there causing, I mean, it has to be there in MATLAB, but it's not supposed to be there in PLECS. That will cause error, but it can be verified using equation. Yeah, this is how I do. I always come and say, oh, okay, then I will try to recall, okay, this is where I learned my circuit theory back then. Okay, fit theory, right? Team, then try. Okay, so all you need is already here for you to complete your assignment. So yeah, I don't see there's any much more big issue. All right. Okay, any questions? So next Monday, we back to normal physical class. I mean, for those online. Okay. Because I just get my booster yesterday. So actually, I'm very tired now. So yeah, don't worry. It won't affect our class. I will still manage to deliver the class today. Oh, okay. Any more questions? Okay, since I cannot save. Yeah. See, very similar, right? Okay. The other question. The other question then. Okay. So if there is no question, then we will end the class today. Thank you. Okay. Yeah, hope you all can learn something good new in PLECS also okay? Trust me, if you go for any postgraduate study or any research institution or any big company like ABB who design all this, you will find PLECS and MATLAB beautiful. So try to get all your team member done by this week Don't leave the form blank, so that I can see how I'm going to arrange all this. 3 in the group max, okay? So there will be only 2 group with 2 students. No hardware involved. Don't tell me that you all cannot meet together you all not in the country. All these kind of excuses